Okay, so if everyone wants to look to their right, what you can see back up on the hill on the far right, the excavation work that's going on there, that's for the tank farm, what we call the tank farm. So there we have 4 tanks. There's 2 fire water tanks, there's a recycled water tank, and there's also a potable water tank. Now the reason we have those is because I guess it is rural water supply out here, so pressure is an issue, and we do have limited capacity as to what we can draw off. So I think we trickle feed during the later hours of the night to about 5 o'clock in the morning. That's the window we have. So that's why we have the tank storages here, because if anything does happen during the day and we need urgent access to potable water or water for firefighting, we need to have that in the tanks, because we won't get it from the town supply. The structure immediately to your right, so that is the MBBR tank. So as you can see, that's around 15 metres long. The walls are 7.5 metres. That's split up into 4 rectangular compartments. So there's 2 compartments on the left, 2 compartments on the right. We call them train A and train B, and then within each train there's a zone A and a zone B for the media. There's media in both compartments. As I said, we poured those walls full height in one lift, and we did the external and internal walls all as one. So we had no joints in the walls apart from the construction joint at the base slab. Has anyone here done water retaining structures, concrete water retaining structures before themselves? Yep. Limited. I guess one of the key risks in doing concrete structures is your joints, because often that's where you'll get leaks. And what we have to do with any water retaining structure is we have to do what they call a leak test. So we have to fill it with water, let it stabilise for 7 days, and then we have to measure the evaporation and the water level drops to identify if there is any leaks, and we also do a visual inspection around the joint. The way I always do joints, and I've been doing it for years, is I'll generally coat the joint with Zypex, a Zypex slurry, nice thick slurry, and then I put a Kuni seal, which is a hydrophilic water stop. I put that, well, it's like a slurry water stop, but I put that down the middle of the construction joint. Now what that does, if you do have any weeps in the joint, they both react with the water and crystallise and basically seal any of those leaks up. As I said, I've been doing that for years, and I'll probably continue doing it because I've never had any problems, and we've done 5 structures here now that way, and they've all passed their leak tests without any issues. So if there's anything you can take out of today, one thing is your joints. Yep. No. 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 We always look at the mixed designs and just getting low shrinkage concrete, and if you do it properly and you cure it properly, yeah, you won't have any issues. Yep. As we drive down, if you look out on your left, the slab that's getting formed up is the UV slab. So we do have UV treatment here, and there is guaranteed treatment levels on that, just to kill all the bugs, all the pathogens before the water's taken to the army wetlands. And the other slab that you see there, the completed slab, that's the transfer pump station. Where those covers are, we've got shafts that go down approximately 6.5 metres, and that's to a collection pipe that comes in off these storage lagoons. So on your left, so we've got twin 2.5 megalitre storages, both lined, with HDPE liners. What you see there is in fact the roof. So there's a base liner, and then we also have a roof, so they're covered storages. When these fill up, they will just float on the surface and they'll just float up and down. In the bottom there's sumps, and as I said, they go around to the transfer pump stations. We did start off with the original design. There was one 5 meg storage, but I guess during our HAZOP and SIDS, it was thought it's best to make them a twin storage, so if there is any issues, you've got some level of redundancy here where you can take one offline or use it. If you have issues with the process, you can put water in there and hold it and then recycle it back through the plant. On the right, the concrete structure immediately to your right is the sludge tank. So that's an aerated sludge tank. Off that, just in front of us will be a sludge silo and then a conveyor into the trucks that will take the sludge away.
Just a quick question, sorry. How do you manage the rainfall on top of the roofs here?
The roofs actually have a drainage sump built into it. So whilst they're sitting in a depression, the water will drain to the sump, and there's a pump there that will transfer it out. So pretty much all our any processed water or runoff that we get does get collected in a drainage system and taken back to the inlet works. All right. Probably talking too much.
I'm just mindful of getting people back. We're going to be back past 12:30, so if anyone's got 12:30 meetings, you might need to cancel them. We don't have to have lunch anymore. Yeah, thanks to John Holland providing some morning tea for us.
Yeah, that was really good. Unexpected and really good.
Thought someone might be peckish after a long bus trip.
Wes on the left, on the right here we're prefabbing our precast panels for the clarifier.
Yep.
If you want to just stop up here a little bit, mate, we'll have a bit of a look out to the right.
So on the right, on your right, the structure you can see with the scaffolding, so that's what we call our clarifier or denser-dag. It's got 2 very small circular chambers in there, which is where your sludge settles out and gets sucked out the bottom. Traditionally those clarifiers would be 20 to 45 metres in diameter. It's a very complex structure inside with walls, suspended walls, baffles. What we're doing here is we've actually got to precast some of the elements and suspend them in there to be cast in. All right. Yeah. You might as well drive up and out now. Yeah. So on your left, that level pad there will eventually become the solar farm. It's a 200 kilowatt, well 150 will become a 200 kilowatt farm. That will supply the base load power demand during the day. So the only power that will draw off the grid will be of a night time. Okay. So has anyone got any questions before we jump off the bus and put you on your merry way? Well, I thank everyone for coming out. I thank Phil and the AWA for the opportunity to host everyone today. I hope you've had a good visit and learnt something and seen something interesting.
Very good, thank you.